Network troubleshooting using Wireshark.
So today what I want to cover is a little bit of Wireshark for the help desk heroes out there. Anyone who is doing desk side support, help desk type support, and maybe you are aspiring to join, a networking team or become a networking analyst or engineer. One of the best ways to get started is to start using tools like Wireshark in helping users troubleshoot, very simple issues that they're having on their PCs. So that's what we're going to cover today. We're going to lay out a very simple scenario for you, but a great learning scenario, show you what it looks like in Wireshark to diagnose a couple of different situations, and leave you with a few tools that you can go and try next time you have an issue at work. So without further ado, here in our scenario is our help desk hero. He is an aspiring, or she is an aspiring CCNA, and wants to start practicing some of the theory they're learning at work. And what's happening in this issue, this ticket that this hero receives, is that the user on this PC cannot connect to a website that lives somewhere on the internet on a server. The server's over here. Okay, so they cannot connect, or they're having issues connecting to this site, and you want to help troubleshoot what's going on. And the way that the connectivity works in this case is that their PC will connect to some kind of local switch within your office. That switch will then connect to some kind of internet firewall, and that firewall connects to the internet, which then connects to the server. Okay, so in order to diagnose this issue, the first thing you do before you get to any captures or any technical analysis is you need to ask the user some very simple questions. And these questions are as follows. Number one, did this ever work? Meaning, was this user ever able to access this website to begin with? If the answer is yes, then the problem may be that access was terminated or something has changed either in your infrastructure or with the target website. If no, then maybe this never worked. Maybe users in your company never had access to this resource, and really this isn't an incident. This is more of a service request or request for access. Okay, so but always start off your questioning with, did this ever work? Number two, can you connect at all, or is the issue intermittent? Is it that you can't get to the website no matter what, or is it you can get there sometimes and sometimes you can't? Because that will help describe to you the underlying issue that's going on, or at least give you some hints about what's going on. So that's number two. And number three, what is the destination, website, host name, or IP address that you are connecting to? Now, many users will struggle with this, especially if they're not technical. Many of them, or some of them, may be able to give you the website. See, I'm trying to get the Facebook and I can't get the Facebook. But the host name or IP address is probably a little bit more advanced. So if you're doing help desk and you're poking around on that user's PC, you may want to watch as they are trying to connect to either the application or the website. And then from there, you can make the assessment about what the actual host name is, the IP or the website, FQDN. Okay. But these three questions are really vital. You can have a lot more questions, but if you're actually asking this of an end user who's not technical, usually they can answer these pretty easily, right? And then from there, this gives you a great starting point to do your capture and actually get started troubleshooting. So back to our scenario, we've asked the user to fill those details. You on the help desk are going to log into the user's PC. You're going to set up Wireshark to do a capture. If you do not know how to actually perform a capture in Wireshark, I will link to that video in the show notes and the description. And it is also in the Wireshark Basics playlist on the channel. But effectively, what you want to do is a wide open capture on this PC to capture all traffic going out to the switch, to the firewall, and to the internet. Okay. Once you have that capture, you can take it back to your PC or analyze it live if you have some kind of like screen control, and then dig in and figure out what's going on. So let's go to Wireshark now. So over in Wireshark, in this scenario, we're going to look at an issue connecting to a server on the internet. So for a given application, say it's like Lotus Notes or some kind of accounting software. And the user was actually technical enough to give me the IP address. The IP is 1.2.3.4. Okay. Yes, that's a bogus IP address that may or may not be used, but for argument's sake, that's what we're using. Okay. So the user gives you that, you do the wide open capture on the PC, and that's what this looks like here. Okay. It's just a wide open capture of all traffic going in and out. Now, to simplify things so that you don't have to go through and figure out what all of these things mean, we want to do a simple display filter. A display filter allows you to filter out all the different traffic in this capture and just down to either the IP address, MAC address, or whatever parameter you put in here. Okay, so think about it like you're actually just reducing all the data here so you can only look at the data you want to look at. And what I want to do is plug in the IP address in this format. It goes ip.addr is equal 1.2.3.4. I'm going to hit enter. Now, so the first thing, which is really good, is that the filter returns some data, meaning whatever I captured, I actually captured traffic from this PC to the IP address that we're targeting. Okay, so regardless of what's going on for the problem, we know we got the data, right? If you don't see any data here matching this IP address, you have to revalidate the IP with the user, maybe have them connect again while you're looking at the screen to see what they're doing. And at the same time, you can pull up a command prompt to validate the information, okay? So in the command prompt, I'll pull it up here, you can first of all validate ipconfig, validate the IP that's on the local PC, 10.0.10.43, and you can see here there's packets originating from 10.0.10.43, so that's good. And then at the same time, you can validate the destination. Now, one thing to note about the destination, in this day and age, a lot of resources, or many resources on the internet, for a given host name, so host name being like the actual www. Canada.com, whatever it may be, there may be multiple IP addresses. So, for example, a user may give you one IP address and then connect to a website, and then you don't see the traffic in the capture. You may need to just validate that. And if the user only gives you the host name, what you can do is go into command prompt and let's look up and let's enter the host name. In this case, it's HSBC China. And what it comes back with is this, is that for that name, we actually have multiple IP addresses. We actually have something known as IPv6 addresses, which generally aren't going to be used only in advanced cases. You'll probably see that. And then you have two IPv4 addresses, which you're probably used to seeing in this format. So this is another way that you can validate what the IP is that the user is actually connecting to, and then actually plug that into Wireshark to see what's going on. This is the other reason why you want to do a wide open capture as opposed to a filtered capture. If you go to that video I mentioned about how to take captures in Wireshark, I cover two scenarios. One is doing a wide open capture of all traffic coming in and out of the server. And the second is using a capture filter to filter and capture only traffic destined to one or more IPs. This is why a wide open capture is useful, because you may be doing a filter on, say, 1, 2, 3, 4 in a capture filter. And then you look at the capture and there's nothing there. Well, it may be that the user gave you the wrong information, or it may be that you have a situation like this where there's actually multiple IPs in play. And so you don't want to have to redo the capture and re-engage the user to say, hey, I need to do another capture and take another half an hour away from your day. You'd rather take as much data as you can at the outset, let the user try to connect a few times and fail, and then you have everything you need to do the analysis afterwards. Okay, so that's one thing to look out for. Now let's actually get to the capture and analyze what's going on. What we see here is a packet to start a SYN, and we see the protocol is TCP. Now we won't go deep into networking basics, but for this website, to connect to it and to connect to most websites, you use the TCP protocol, which the first packet in any sort of TCP conversation is known as a SYN packet. Okay, TCP has this handshake where it goes SYN, and then the other side sends back a SYN ACK packet, ACK stands for acknowledgement. And then there's a final acknowledgement from the initial person, which is me. And then the data can transfer. But for now, all we see is the SYN. Now, thinking about communications, if this communication is successful, meaning that you're able to connect to the website and actually download information, you should be seeing packets go in both directions, meaning from me, the source, to the destination, and then from the destination, which should be in this column, back to me as the source. So a healthy TCP conversation should show packets going in both directions. You should see 43 as a source and .4 as the destination. And you should see some packets as .4 as the source and 43 as the destination. But in this case, we only see one-way traffic. We see traffic that's heading to the destination, but nothing coming back. So right away, you can see there's a problem here. This is likely the reason why the user can't connect. And it does look like something to do with networks or network services. So what can that be? Let's go back to our diagram. So what we're effectively saying is that this PC is connecting out, going through here. And at some point, its SYN packets, or connection requests, are not being responded to. So what we can imply is a couple of things. Number one, the firewall could be dropping that packet, which is a common issue, right? Sometimes you have a corporation that has a very, very strict security policy where only certain websites are allowed out to the internet, and your own firewall at your company could be dropping that traffic. That is a very common root cause. You, in this case, would then contact whoever is responsible for IT security or network security at your company and open a ticket or transfer the ticket and say, hey, can you check the firewall to make sure that we permit the IP address 1.2.3.4? And they can look at the firewall logs at that point. The second possibility is that that SYN actually did get through the firewall, got through the internet, and got to this server over here. Now, if it got to the server and the server's not replying back to you, it could mean a couple of things. It could mean that the server has its own firewall. So say there's like a firewall in front of the server blocking all traffic coming in. That is a distinct possibility. In which case, you may need to actually get permission from the company you're connecting to actually connect. We know that we call this an IP whitelist. Okay, I'm just going to do a W. And this list is basically a policy of which IPs are allowed to connect to the server. So in that case, what you would need to do is figure out, well, who, like, is this website like from another company, like a B2B organization that we have a relationship with? Is this the vendor that we pay for services from or for? And contact that party, that resource who owns that server to say, hey, do you have an IP whitelist? And if so, do you actually permit our company from connecting to you? That is certainly a possibility. The second possibility on the server side would be that maybe they're not actually listening for that connection. Like maybe the user thinks that this is a website that they can connect to, but maybe that server actually doesn't offer that service anymore. Maybe it took down the website. Still, with that scenario, you would contact the vendor or whoever owns this website to be able to figure out what's going on. But if you do confirm, like I say, your network security confirms, yeah, that the traffic is permitted, then those are the possibilities that would exist over here at the application server. Now, the third possibility, which has happened to me a number of times, and yes, I did start my career in Helpdesk, is that the user just didn't know what they were doing. So say you have like a user over here and they are unhappy because they can't connect. They may just have had a bad day and have tried to connect to the wrong website with the wrong IP address. That is also a possibility here. Now, you can use various ways of confirming that. You can ask other users who are in their business group what they do, ask their manager, look at logs, things like that. But don't discount that. And that's really why when we talked about the questions to ask, asking if this ever worked is really important, right? It's because you get a little bit of information about, well, maybe this is a new thing that this person kind of dreamt up, or is it maybe an actual outage where something that was working all of a sudden stopped working? Okay. So that is a scenario number one, where you get the capture, you see the traffic, And you see that it's unidirectional, meaning it's only going in one direction from the source to the destination, but you don't see anything come back. The next scenario we're going to cover is what happens when you do see a connection, but there's problems with the connection. So scenario number 2 is this. The user says, well, I can connect to the server I want to or the website, but it's slow. The performance is bad, right? And in these scenarios, it's often difficult to understand what they mean by that, because what is bad? You know what I mean? Like, how slow is slow? Is it slow to you, or is it slow, objectively slow? And that's really what you need to try to understand if you're coming at this from a network perspective and you're trying to make sure that the network itself is healthy. Because if you look at the scenario, and pardon my pigeon scratch, slowness can be a number of things, right? If you're a help desk hero, you got to think about all the components that could be causing this, because you may need to engage other teams to kind of figure out things, right? But let's have a network focus for now. Slowness could be the PC is slow, right? Slowness could be there's something in the network between here and there that is slowing things down. Slowness can be that the actual application server is slow. The website itself is slow, right? It could be running out of resources. It could be under denial of service attack. It could be having an incident itself, right? That the vendor has to figure out. So if you're putting on your network hat, what you really want to try to prove or disprove is whether or not there's anything in the path that is disrupting the traffic from getting back and forth to the server in question. Okay, because that's really the function of the network. Think about what the network is designed to do. The network is designed to get traffic from you or from whatever devices are on the network to other devices, even on remote networks, with little to no disruption, meaning little to no loss, and latency being within acceptable limits, right? So we're not going to go into too much theory, but really what we need to do in this scenario is figure out, how do I tell if the connectivity is good or not? How do I tell if we're actually dropping packets, or if the network traffic looks good and therefore the problem might be here or the problem might be here? So let's get back to Wireshark. In this scenario, the user has told us that the issue is with a server that has the host name, and don't make fun of me for this, chocolate.local. So we're going to do ns lookup chocolate.local. Okay. And we see that the IP address is 10.0.10.150. So I'm going to copy that and minimize this. I'm going to do, in my packet capture, I took a wide open packet capture while the user was trying to do this connection to the server. I did it with them so I can actually see what they were doing and make sure that the capture settings were correct. And I'm going to do ip.addr is equal to 10.0.10.150. Let that go. Now, let's go right to the top of this. First thing is this. Remember in the previous video, I said that the traffic was unidirectional and that the SYN packet was going out, but there was no SYN ACK coming back. This is what it looks like when TCP is actually good, meaning like you have bidirectional communication between the source and destination. We actually see a number of different conversations here, but for now, that's okay. I'm just going to leave it like that because we're not going to get too deep into TCP. But the number one thing you can tell from this is that I can communicate with the remote server, and the remote server can communicate back with me. Okay, so bidirectional traffic exists. If I go back to this diagram, that would mean that I can get my traffic through the firewall to the destination server if it's behind the firewall, and destination server can get the traffic back to me. So that's at least one thing. Access is there. Data is being transferred. It's just something is slowing it down. So let's see if we actually could see the slowdown. The next thing you want to look for when the protocol is TCP. TCP has a mechanism where when packets are dropped between the source and destination, TCP will retransmit those packets. Meaning, if I send a letter to you and the letter doesn't get there, the mail service is going to send that letter again until you get it, right? Now, TCP will show you those packets and mark them as black, okay? You can see here, you see a TCP fast retransmission. So when you see this in a capture to an IP address, what you could start thinking to yourself is, I think there may be some packets that are being dropped between the source and destination. Okay, because that's how Wireshark will mark these. If you don't have any packet loss, the packets will just show up with this color here, or whatever color that they are from the start. When you do have things like packet loss or and retransmissions, then you're going to see a few different types of messages. You're going to see retransmission, you're going to see duplicate ACK, you're going to see out of order, but they're all going to be marked as black. So think to yourself, if I start seeing black in this packet capture, that implies to me that, yeah, it looks as though there's actually traffic being dropped. Someone's network or part of the network might actually be responsible for the slowness. Okay. The other way you can actually confirm that is as follows. So let's say I have this IP address and I want to do a filter to just look at retransmitted packets, because if this file transfer is perfectly clean and the network is not disrupting it at all, you should see 0 retransmissions, meaning no black packets at all. But I clearly saw some, so I want to know, like in my head, how many there are. So let me do IP address 10.0.10.150 and tcp.analysis.retransmission. Enter. And right away, I can see that there actually are quite a lot of retransmissions between the server and my PC, right? So what could be causing that, right? Let's get back to our diagram and take a look. So back to the diagram, I cleaned it up a little bit so we can actually have a fresh start. So we detected that there is some packet loss between the PC connecting and the application server. So what can actually cause that? Now, remember, there's network connectivity between all these components, and this is a very simplified diagram because really most corporate networks aren't going to be this simple. You're not going to have one switch, one firewall, and the internet is not cloud. But all you can think of in your head is that all of this represents network gear and network components. So you have cables, you have adapters like optics, you have switches, you have routers, you have firewalls here, right? All these things are network components which are required to transmit data between destinations without dropping it. So if you are seeing that packet loss, then it could be that something on your own network, right, is faulty. Maybe you have a bad cable. Maybe you have like an old component that needs to be swapped. Maybe you have a switch that has high CPU or memory issues. It could be the firewall that's having the same kind of issues, right? It could have physical issues. It could have hardware issues, logical issues. It could also be that the public internet is having issues. Not many people think about it this way, but the internet is really just a series of networks, right? It's a series of tubes, but in reality, it's a series of networks. There's other people's networks and large scale enterprise provider grade networks. But they all have components just like your network has components. They have switches, they have routers, they have cables, and that can be problematic. So at this point, if you do detect that as Helpdesk Hero, you'd probably start with opening a ticket or transferring the ticket to your network operations group, to your network admin, whoever it is, and say, hey, look, I think I can see some packet loss between the PC and the server. If you want to be like a real friend to them, give them the details that you capture, like give them the capture file, give them the IP addresses and whatever observations you had, and see what they say. The other thing I would suggest highly is that, again, if you're trying to learn how to do networking, want to get a network role, keep an eye on that ticket, right? Or ask the network analyst what they're doing. Like, can they show you a little bit about what they're going to do to troubleshoot? Because likely they're going to do things like they're going to do ping tests between components. They're going to look at statistics on switches to see if there's any drops or errors. They're going to do their own tests, like maybe they'll use their own PC, connect to that website and see if there's issues. All those tests are really valuable to learn, and they're out of the scope of this video, but it's a great way of you showing that you have an interest in network issue, actually helping solve the problem because you did detect that, hey, this website is connecting. It's just something is going wrong. It's just going slow. Providing information to the network team to actually help them start the investigation. You're not just dumping work on their lap. You're saying, hey, I'm kind of trying to learn and I wanted to help out. And here's what I found so far. And can you help me figure out this issue? And doing that repeatedly actually helps you build these skill set. And every time you do, every ticket, you're going to learn a little bit about, where these things could break. Because if you learn where these things break, it becomes easier and easier for you to troubleshoot. And then all those things that you're learning in your CCNA, boom, they start to formalize. Okay? So 2 scenarios, a few tips and tricks. If you are in Helpdesk, I highly recommend you start using Wireshark to help diagnose some of the issues that you're working on. You can look at my video, Why Learn Wireshark, to understand why it's so important to understand Wireshark and learn it, even if you're not in networking. And again, if you have any questions or issues that you're working on that you want advice on, join our Discord or send it in the chat or in the comments, and I'll certainly get back to you. That's it for this video. If you have any questions about Wireshark or networking, feel free to post it in the comments. We can chat about it there, or you can always send me the capture file to take a look at. I have a Dropbox that I'll send you to send the file. I've also got a Discord server now, so you can check it out, that channel, and join to do the same, post questions about networking, issues you're working on at work, etc. And as always, please like and subscribe to support the channel. Until next time.